and welcome everybody to our Data Science Festival Game On warm-up event, proudly sponsored by dunnhumby. We've known the team at dunnhumby for a very long time. We are now in our 9th year running the Data Science Festival, and dunnhumby actually were involved in our very first year. And since then, they have been amazing partners, really supportive of the data community globally. They've been involved in our in-person events in the UK, but really proactive in terms of bringing content to our global community as well. And that's absolutely what we're doing today with our Game On warm-up event. In terms of Game On, super quickly, if you are joining us from the UK, we have got our conference on Saturday. This is the kickoff for it. So we're aiming to have some good fun and get the learning started a little bit early. Again, one other call out, we have recently just launched another sandbox session with our good friends at Deliveroo. We will put that into the chat and go from there. In terms of today, we're joined by Vindhya and Ramesh. We're very much looking forward to hearing them talking about AI, machine learning and optimization, the key to revolutionizing personalization in the competitive retail landscape. So if it's okay, Ramesh and Vindhya, please turn on your cameras, turn on your microphones and come and join us on stage. Amazing. Good to see you, Ramesh. Hopefully Vindhya is right behind. There we go. We have some speakers. We're off to a good start. We're off to a good start. Good to see you both. How has your day been today? I'm guessing it's maybe what, 5:30 where you are at the moment.
Yes.
How's your days been?
It's been exciting. We're excited for the session.
Amazing stuff. It's good fun. We have a good community of people. So they're all super friendly. I'm sure they'll be jumping into the chat and being supportive and saying hello and wishing you all the best. What about yourself, Ramesh? How's your day been?
So it has been really good. So we were just waiting for this event to start. So I think we're excited and want to dive in.
Amazing stuff. Amazing stuff. I am going to stop sharing my screen. And Vindhya, we will ask you to please share your screen. I'm going to do a little bit of Zoom admin as well. With the webinars, the majority of people join as attendees. I'm not sure, Vindhya, if a couple of people may be using your host link as well to join the webinar. In terms of that, Maddie, is it possible for some of these extra people that have joined on the back end to be moved to attendees rather than speakers?
Yep, that's fine, doing it now.
Amazing. Thank you very much. We'll keep a little eye on that as the sessions progress. Maddie will be able to take care of that on the back end. And in terms of now, Vindhya, if it's okay, please could you share your screen and we'll get ready and we'll go from there. In terms of that, I have kept the introductions relatively quick in terms of both of you. So when you do start, please do tell the audience at home a little bit about yourself, what you do at dunnhumby, and a little bit about your background. So in terms of that, final bit of admin from me. As mentioned, it is an interactive session, so please do say hello in the chat. It's always nice to know people are out there. Let us know where you are, what you're doing. And if you have any questions, my ask would be please use the Q&A feature. And then as Vindhya and Ramesh finish, we've allowed some time at the end to talk through the questions. So that's the only last bit from me. In terms of that, the screen looks great, Vindhya. So if you're happy, I'll get out the way and hand over to you.
Sure. Thank you. Thanks so much, David. I think both myself and Ramesh are pretty excited for this session. Good morning, good evening, good afternoon, everyone from whichever part of the world you are joining. I am Vindhya Kapoor and I am an applied data science manager at dunnhumby. I have been working in the retail sector for almost 14 years now and 12 years with dunnhumby. I started my journey with dunnhumby in 2013 in the customer engagement and media expertise work stream. And I have moved roles since last 12 years and I have worked across various geographies, Asia, North America, and now I'm currently looking after a big retailer in the European region. So that would be my quick introduction. And before we move into the session, Ramesh, please introduce yourself as well.
Have we lost Ramesh? I'm not even sure he's still in here. Is he left, Maddie?
No, I don't think he's here anymore. I'm just going to email him.
We are going to promote him back to a host. Ramesh is in the audience now. This is the magic of Zoom, isn't it? He's gone from the stage into the crowd. So I'm hoping Maddie can pop him back to being a host, if that's all right. I'll fill. I'm a pro at this, Vindhya, as always.
That's fine. I think we still have a lot of time. So
yeah, we'll be good. We'll just double check this is happening. I like to think of Maddie just sweating away in the background as well, try to work out how to make Zoom work, which is always good fun, isn't it? So it may be that, there we go. The power of technology back on the stage. Here we have. A round of applause. I love a little clapping emoji as well. Stick some emojis on for Ramesh coming back. Ramesh, I will get out the way. I'll hand back to both of you now. So I think we were looking for an introduction, please, for Ramesh. There's party emojis going. There's thumbs up. We've got a webinar. Back to you.
Thank you, Maddie, for bringing me back. So like Vindhya, I have a total experience of 13 years. I've spent most of my time in dunnhumby. So it has been a decade in dunnhumby. So I did multiple roles in dunnhumby, starting from data science to product development to AI. I think this has been the journey. And today we'll focus on one of the key projects that we have been working with a lot of passion, and we'll want to share that with you. So without any further ado, I'll hand it over to Vindhya so that we can learn about a great methodology. What do you, Vindhya?
thank you so much, Ramesh, and thank you, David. I hope we are all past all the technical glitches and we can just dive into the session now. Hello, everyone, and it's an absolute pleasure again for myself and Ramesh to be talking to you all at Data Science Festival about one of the most transformative forces which is shaping the future of retail, which is the emergence and the convergence of AI, machine learning, optimization, and how this trio is actually opening new frontiers in personalization. We all know that today's retail landscape is hyper dynamic, it's hyper competitive, where customer expectations are no longer linear and static. They are dynamic, they're ever changing, changing day by day. And customers want a highly individualized experience today. And that is where you see most of the generic marketing strategies, they no longer move the needle. And to really be at a cutting edge, all the retailers, must not only know who their customers are, but they should also know where their customers are, what they want, and how they want it. And that is where the power of these techniques come into picture. Of these just don't learn and predict, but they also adapt in real time. So in the next few minutes, we will explore how these techniques are being used by retailers across the world and even dunnhumby to create a cutting edge personalization and deliver smarter, faster decision making for our clients. We continue to push the boundaries with these techniques with more responsible action, intelligent, action driven insights, and obviously creating an impact for our clients. So before we move on, I'm very happy to introduce again what dunnhumby is and what do we do at dunnhumby. At dunnhumby, we certainly believe in the fact that we can create a better world by putting customers at the heart of every decision making. dunnhumby actually is a global retailer in customer data science, helping retailers and brands across the world make smarter and faster decisions for their customers and understand and serve their customers better. So through the use of AI, data analytics, and deep retail expertise, dunnhumby actually enhances the customer experience at every step of the customer journey. And some of the key areas where dunnhumby excels or pioneers in are these 5 areas, which starts with data strategy, consulting, customer strategy, insights, enhancing personalization, loyalty, as I already mentioned. We also design effective pricing and promotions tools and optimizing category engagement. In terms of our network, we have a very wide variety of networks spanning across the globe, from Asia to EMEA to Americas, currently serving more than 56 retail clients, partnering with more than 1250 plus CPG clients, And we also are transacting across 1 billion of customer and 30 billion of transactional data on a daily basis. That's the power of dunnhumby in front of you. And at dunnhumby, we never stop innovating. We love our clients, we love our customers, and we always want our customers to keep returning time after time. So here we are with a very interesting agenda. We will start by understanding evolution of retail and how today we are already in the era of hyper personalization. Then we will see how dunnhumby is moving a step closer to hyper personalization by understanding the customer offer science with a very powerful predictive modeling case study that we will showcase you. Then my colleague Ramesh will talk about campaign optimization using the new state-of-the-art AI techniques, spectral clustering and graph neural networks. We will close with some findings, challenges, and then the floor would be open for Q&A. So let's dive in. Now, what you see in front of your screen is a very simple example. This is a scenario. We'll talk few scenarios, and this is the first scenario that I'm going to talk about. This basically gives a message that there used to be an era of mass offers. So see, you see a customer here, Bob, hypothetical, who is pretty sad and bombarded with same kind of offers, all the time, and this has led to a sense of him being overwhelmed, and a sense of being ignored by his favorite retailer. And then comes the AI powered engines, for his rescue, which kind of help predicts and analyze, what Bob really wants, as a personalized offering. And now you see that Bob is pretty much happy with the kind of, relevancy that he's getting across different channels, through emails, on his app, and maybe a different one in store, and he feels that these offers are actually made for him. Now let's look at another example of a customer named Alice. She sees a promoted healthy post, while browsing Instagram during lunch. Then after a few hours, she sees an email popping up which says a 10% off on her protein rich snacks. Then she goes to a store and she sees the same app recommending a buy one get one on her favorite Greek yogurt brand. And then the same app recommends to add a protein bar at the checkout. So, what does this example signify? It signifies that from product discovery to checkout, every step in the customer's journey is now hyper personalized. So, let's talk about the evolution of retail. The pre-1990s era was a pretty simple physical retail. You walked into a store, you browsed some shelves, you spoke to a salesperson, and you made a purchase. It was a mass marketing era where it was primarily dominated by brick and mortar stores, and it was 100% offline heavy retail. Then we moved to an era of 1990s to 2000s, which was called the traditional targeted retail, where we saw retailers launching their loyalty programs, store promotions, mass promotions happening, and even some basic segmentations kicking in like customer age, customer demographics, etc. Then 2010 to 2020 saw an era of data-driven personalization, which was all about the booming of the e-commerce retail, and even recommendation engines, personalized emails, and omni-channel experiences started to kick in. And now we are in the era of 2020 and beyond, which is already an AI-driven hyper-personalization era, where you can say is a lot dominated by the shopping patterns, of Gen Z, Gen Alpha generations, virtual chatbots, voice and virtual assistants, may be called as a true personalization at scale. Now, let's talk about some of the key elements that forms the foundational bedrock of any hyper-personalized retail journey. So it all starts with first, which is the data. So the richer the data, the deeper the insight. So data forms the foundation of any good hyper-personalized retail journey. In some of the examples that we have listed here, you can see from browsing patterns to transactions to geolocation data to engagement data, social media data, whatever and how much data you can think of, all comes as a first step in designing a hyper personalized customer experience. Then on top of this data, when we apply AI-powered analysis, this is where we get some meaningful insights out of this data. And these techniques help us drive meaningful recommendations and next best action strategies. The third is the contextual relevance, which is you want to reach to the customer wherever the customer is. And that can happen through a lot of channels like push notifications, in-app purchases, uh, store exclusive rewards, member pricing in store, etc. And then tying all of this together are the privacy and the feedback loops, which has become very important in this day and age. So all the retailers, agencies, and third-party agencies that we work with, we make sure that we maintain the and respect the customer boundaries, whether the customer has opted in or opted out of a campaign. We only target those customers where we get customer consent, and we maintain these data boundaries and customer control so that we are able to build long-term loyalty for the customer. And when all of these four areas, when they're integrated in a seamless integration across different channels and devices, is where you get the full omni-channel experience for the customer. So I hope till now you are with me and you have got a gist of what we are trying to explain in terms of setting the context around hyper-personalization. Now let's talk about how dunnhumby has already entered this phase of hyper-personalization by understanding the campaign lifecycle and the customer offer data science that we excel at. Okay, so how does a typical campaign lifecycle looks like? Any great marketing campaign has these 5 or 7 crucial steps. The first step is the objective. Whether you want to reward a loyal customer, acquire a new customer, or cross-sell or upsell an existing customer. Then comes your audience. Again, whether you want to reward your loyals, grow your opportunity customers, re-engage your lapsed customers, or win back your gone away customers. The KPI that you are trying to measure comes as a third step, which is a very important step, which has to be very clear what we are trying to achieve out of this campaign, whether we want more participation from the customers, whether we want more repeat purchase from the customers, or it is just about driving sales from the customers. Then comes the channel strategy, which is again reaching the customers where he or she is, which can again be through different channels listed here. Then forms a very important concept of offer and how do we want to communicate. So the creative, the communication becomes very important. And this is where the next two techniques we are going to focus on a lot. And then is the closed loop measurement. So as soon as we start to get the data from the first party data from the retailers and other data feeds, we monitor results on daily, weekly, and monthly level campaign. And again, tying all of this are the strict GDPR and customer consents that we maintain all across the full campaign lifecycle journey. Now, moving on, you must have seen me speaking this term offer a lot. So what exactly an offer means? An offer can be in a synonym way called as a coupon. But the offer science is a very wide word. It actually means creating smart offers, right offers, which not only balances customer engagement, but also drives business profitability. So it is always about finding the sweet spot of designing the right offer for the right customer at the right time using data-driven insights. As a shopper, we all shop with our favorite retailers, and these I have listed some of the offers that we encounter on a daily basis. So when I go in store, I can get a product offer, which is a simple percentage off or a discount off. I can get a points offer. I can get a buy one get one. I can get a free sample as well. I can even get a very generic offer on my department and seasonal offers like Mother's Day, Easter, Christmas. So all these are different kind of options, which as a customer we encounter on a daily basis. Now, when I or you as a customer have a plethora of options around these offers, how do we as data science organization make sure that we simplify and we customize the experience for every customer? And that is where we tie both the customer and the offer science together into a package called as an allocation science. And I will tell you step by step how this allocation science works. It all starts with providing some basic inputs like some campaign details, the time period on which you want to run the campaign. You provide some product exclusion list, maybe some products which the retailer doesn't want to promote, maybe some basic discount that you definitely want to give to a customer to attract the customer. So this forms the first step, which is getting all your inputs in place. The second step is when all these inputs are there, we put some rules, some business rules, like, we want to see how much customer is generating sales, basket penetration, how much the product is popular with the customer. And using a weighted average of these scores, we create a set of offers. The third step is when we match these offers to the customers using some relevancy signs and other KPIs like purchase cycle of the product, the recency, frequency, and the monetary value that the customer is driving on the product. And the fourth and the last step is when these offers are finally issued to the customer. Now, these rules have been working well as a business for us, and they have given us promising results. But there always lies an opportunity with the rule-based system, and there are some limitations with the rule-based system, which is there's always some manual intervention which is needed with this rule-based approach. So as the new data is coming in, this rule-based approach is not very flexible and agile to put all the new data because we have to revise all the rules all over again. And second, there is no scope of impact simulation. So suppose before launching a campaign, I want to try a lot of tests and trials and see different approaches, which is giving me the best result. I can't do that. And that is where the rigidity of this rule-based approach is not very promising in the long run. So to move away from this system, we developed a new predictive science, a more science-backed solution, I would say, which can actually, help us, create an edge over the rule-based system. And that is where we developed a sophisticated ML-powered algorithm, a predictive model, incorporating 30 plus features, so that we are able to capture customer responses with much greater accuracy. Now, to build this model, we have taken 26 weeks of data, starting with Q4 of 2023 to Q1 of 2024, which is roughly from October 2023 to March 2024 was our training data set. A mix of pre-period and campaign period features have been introduced in the model, and I will talk more in detail about the features in the next slides. But they are primarily engrossing all the 4 areas, which is transactions, product level, customer segmentations, offer level features. The model right now is built for more than 2,000 products because that is a good sales coverage that we get for any retailer. In terms of using different predictive techniques, we have tried a lot of tree-based models, and to capture the complexity of the data, we finally narrowed down to XGBoost approach. And we have also used a 5-fold cross-validation technique so that to ensure that the model doesn't overfit or make any biased predictions. And the same model has been scored for these 2,000 plus products for Q2 2024, which was the time period from April to June. Now, in terms of the feature selection, as I already mentioned, the features were selected from 4 broad areas. From product level, we had interesting features like elasticity and customer importance score. Elasticity basically tells whether the product is elastic or inelastic, which means if I change a unit price in a product, I can see whether the sales of the product are getting affected too much or not. The second is a customer importance score, which is how, if I change a product, what is the customer perception towards the price perception. Then in terms of the transactional level KPIs, we had sales, units, visits captured not only at the product level, but also at the higher hierarchy levels, which was department, section, division, etc. Customer segmentations are very important for us as a business, and we make sure that we have a good representation of those customers, especially the price sensitive and the loyal customers in our model. And last are the offer level features. I think in last 1 year, whatever type of offer that we gave, like, it can be a money off, it can be a BOGO offer, We have also introduced all the different kind of discount amounts and tactics that we introduced in the model. So overall, we had a good number of 30 to 40 variables to start off in the model. And let's see the model in action. How is it performing currently? We see an example of two offer types, which is buy X, get Y in a flat discount. Now, suppose I change the discount from 0.25 to 0.5. I see that the redemption rate moves up from 5.8 to 6.1%. And then when I change the offer type from flat discount to buy X, get Y, I see again a drop in the redemption rate. Now, what does this tell you? This tell you that predicting redemption rate in advance has a lot of benefits. Because you're able to calculate number of redemptions in advance now, we are also able to calculate the redemption cost in advance. And with both of these, we are able to also calculate the return on investment of the retailer or the brand. And that is where we see three clear benefits coming out of this predictive model so far, which is now the model has a lot of scope of impact simulation, which means if I alter any of these features, input features, I can see how these three key metrics, which is the redemption cost, the ROI, is changing. And that is where it gives us as campaign planners a lot of confidence and freedom to move around with a test design. The second is informed experimentation. We can do all of these strategies and try all of these strategies a lot in advance before launching the campaign. And that actually helps us in planning the campaign better. And third is the feedback loop. So we have moved, the needle, from the rule-based approach to now a predictive approach. And the model is very flexible, agile, and it can also adapt in real time. So these are the benefits that we are seeing from the model upfront. But as a business, since I mentioned, we just don't stop here. We keep innovating. And this is just one part of the story, which is predicting the redemption rate. The another part of the story is how we can build this further as a bigger optimization problem. And that is where I would pass on to my colleague Ramesh to talk about spectral clustering and graph neural networks. Over to you, Ramesh.
Can't live with silence. I have to come back and just fill it. Ramesh, hopefully Ramesh is flicking.
Yes.
You're taking control. Has it worked?
I believe it did.
Mate, good stuff. If you flick your camera on and then maybe just flick it forward and back a slide just to test that that's working.
I hope you can see my slides.
We can. Yeah, if you flick it forward a slide, well, maybe, yeah, that works if that was you.
All right, so
Yeah,
thank you,
amazing.
David. So hello all. I hope you are having a fantastic day. So far, what my colleague Vindhya has explained, what offers are, and what is the allocation or the recommendation process, and how you can optimize it. And in this section, we'll walk you through a very similar workflow. However, we'll be approaching this from a different angle, because when Vindhya approached this, she took an input as is. However, we want to address this problem from the core, and we want to address this with a deeper understanding of the interaction happens while creating the offer and in the recommendation process. So in this section, we'll explore offer creation using spectral clustering, and then personalized offer recommendation using graph neural network. I'll use some dummy data, and I'll be focusing more on explaining the concept rather than the actual project, because the project has a lot of deeper nodes to it, and that cannot be covered in the limited time. So coming back to the topic, both spectral clustering and graph neural network are based on graph theory, and you'll learn the mathematics behind it in a while. However, the biggest question is that why do we need the spectral clustering? So traditional offer creation used rule-based or grouping of categories or any product hierarchy that misses the nuances of customer behavior. They ignore how products are co-consumed, how preferences evolve. Spectral clustering addresses these gaps by uncovering the deeper product relationships. With that, let's start to understand the spectral clustering. So spectral clustering is a method of grouping similar items by looking at how strongly they are connected or related to each other. It looks at how closely products are related. For example, how products are bought together. So the first thing to spectral clustering is the its input. So we used a lot of product attributes. For simplicity, I've used some example called brand, category, pack size, etc. as input, but there can be hundreds of different features that can be used. For transactional attribute, we used purchase frequency, and promotional sensitivity. Now let's understand the co-graph creation. So co-purchase graph is the main step in terms of identifying the hidden patterns. So co-purchase graph is a way of representing how products relate to each other based on their real shopping behavior. Let's take an example. Imagine that you're in a store, just watching what people put in their baskets. One shopper comes by Greek yogurt, granola, and almond milk. Another one picks up potato chips and protein bar. Now you don't know what they are planning to eat, but you notice some of the items show up together a lot. So, so to do that, you put all of these items on as dots, and the relationship between whenever they are bought together, you draw a line, and that's how you create a co-purchase graph. Then comes the aha moment. After repeating this exercise, you realize that some of the dots are very closely connected, and they must belong to the same group. And that's how you classify them into different groups, and they can be clustered together, or they can be called offers. Now let's understand the math behind it. So for simplicity, I've taken some dummy example. I'll continue with this same 5 products that I talked about earlier, like Greek yogurt, granola, almond milk, potato chips, and protein bar. And the table has a lot of attributes around it, and it can be represented on the left side of the screen. The other is the transactional behavior. So I've represented transaction as now. Next step after input was the co-purchase graph creation. So co-purchase graph creation has 3 steps. So first step is calculating the similarity matrix, then calculating the graph Laplacian, and the last step is to create eigenvalues and eigenvector after decomposing the Laplacian matrix into lower dimension, and then finally creating these clusters. So without any further ado, let's talk about the step first. So the first step for creating co-purchase graph is to create a similarity matrix using 2 scores. One is called Jaccard score, the other one is the cosine score. So let's understand a Jaccard score with an example. You can just follow the colors. That magenta color represents your Greek yogurt and teal represent your granola. So that's Jaccard similarity between 2 products can be calculated, that if the products are purchased in the same baskets, they are considered as one component, and if they are present in different baskets, they are considered as the other component. So in this example, there are 2 instances where both of them are coming in the same basket, and uniquely they are available in the 5 baskets. So the Jaccard score would become 0.4, and similarly rest of the calculations are done, rest of the interactions are calculated. Now next step is to calculate the cosine distance. Cosine distance quantifies how similar 2 products are based on their direction in feature space without relying on their co-purchase data. So let's calculate cosine distance for Greek yogurt and granola again, using features like price and promo sensitivity. The output comes out to be 0.83, and you can use the below formula for reference. Similarly, it is calculated for everything. And since cosine distance is a very common technique, so I'm not going into the details of it. Now, finally, let's create the final similarity matrix. So for that, we have used the combination of both. We have given 70% weight to the Jaccard score and 30% weight to the cosine score. You can choose a different combination. However, we wanted to give a higher weighted to the product where which forms a basket, and the table gives you the calculation for each and every product that we saw earlier. Now, we need to perform the next step is to sum everything together. So we are summing up the entire row to create a degree matrix. And now this degree matrix would be used for us to calculate the actual Laplacian. All right. I hope you guys are with me so far. Even if you don't understand the example, I can think we once we go into the uh, allocation process, you'll get to know more about it. So next step to create a graph Laplacian, which helps in revealing the natural boundaries and the graph densities, which helps us identifying the natural boundaries of a cluster. So originally you saw that we created a degree matrix, then we converted this into a diagonal matrix, and then we did a very basic calculation, which was called the Laplacian calculation. The mathematics is it's a subtraction of your uh, degree diagonal matrix to the similarity matrix, and it helps us identify the natural cluster formation. So the yellow highlighted part gives you a method that now you start to see some of the patterns in this data. However, they may or may not be visible by just observing them. So we need to do further steps to actually reveal the actual clusters. So to detect the cluster, we need to do some dimensional reduction using eigenvalues and eigenvector. And this is for that you used a very similar concept that is used in principal component. Yeah, we have decomposed the eigenvalues by breaking the Laplacian matrix into eigenvalues that denote the separation in the cluster and eigenvector that forms a new space called spectral space. Since the cluster the data is now converted into lower dimension, now we can use very basic techniques like uh, k-means clustering to cluster them into smaller groups that can be called offers. So we have offer one, which groups Greek yogurt, granola, and almond milk, and the cluster two, which is snack, which is where potato chips and protein bar are available. Uh, and then we apply some business rules. Although we considered a lot of variables into creating of this cluster, but there is a sense check that needs to be done. We need to make sure that no brand are no competitive brands are part of the same offer. There is a logical grouping that we are creating offers within the categories. We are not spreading the category too much. There is a minimum size of the products are available as an input. All right. So far, we have understood a method of grouping similar product together to form offers, right? This was the part when they explained in her example as well. Now we would want to focus on the recommendation where we use the allocation process. So in this step, we'll focus on how do we give the right offers to the right customer while making sure we are following all the business constraints, like making sure redemption rates are maximum, relevancy is the maximum, we are incurring less amount of cost, uh, and we are also maintaining the budgetary constraint as well. And again, don't worry if you don't understand the mathematical concepts. Understanding of this concept is not important today. We want to walk you through how how this methodology can bring recommendation to life and bring more. This time I'll be using some graphical notation rather than the tabular structure. Like previous section, I would put another disclaimer that we will be focusing on the graph neural networks concept, not the theory behind graph neural network, and we'll focus on the recommendation part of it. And I'll use some different examples to represent offer than what we created in the previous section, so that it's easier for us to relate and understand. All right. I hope you can relate with this diagram we just saw while creating the spectral clustering. The next part is the offer recommendation using graph neural network with the smart loss function and the losses I explained earlier. At a high level, a GNN allows us to learn pattern over a graph structure data. So in this case, customers and offers are act as nodes, and edges represent their interactions, which can be their redemption, they can be co-purchase, even their browsing behavior. This structure let us learn from the context around the node, not just who bought what, but what kind of customer buy what kind of offers under what conditions. Similar to spectral clustering, there are 5 steps to create a graph neural network based recommendation system. So everything starts with input data creation, then we create a graph, then we'll understand what is a message passing, and then we'll do some prediction and then scoring, and then we'll understand the loss function, which helps the network to learn from its surrounding and optimize the key constraint that we put on top of it. So once this is done, once the final recommendation out, then we can use this information for giving personalized or hyper personalized offers. All right. So let's understand the feature creation. So for that, I'm taking the same example as Vindhya, Alice and Bob. Both of them can have different features. They can have age, spending habit, category preference, redemption rate, household size, and so on. Again, these are some sample attributes that we have used, but in the real project, the attributes were different. Then we have few product. We have oat milk and a protein bar and a Greek yogurt, and each of them can have their different features like brand, category, discount, sensitivity, price sensitivity, redemption cost, and so on. Like I explained in the beginning, customers and offers are considered as nodes in a graph neural network. So I hope you're clear with the inputs to the network. Now let's understand the graph creation process. So graph creation process allows GNN to learn from the cross entity pattern, which means how customer interact with product characteristics, and these can be uh, number of purchases, number of redemption, days since last purchase, quantity per basket. In this example, Alice has bought milk 3 times and redeemed 2 offers. She has looked into a protein bar but didn't made any purchase. I think we did notice that when offer was shown to Alice, she looked at the offer but did not redeem when they explained it. And while Bob has bought Greek yogurt but hadn't redeemed any offer. So these interactions are called edges. Now let's understand message passing. Message passing is the heart how graph neural network learns. It processes where each node, like customer or product, share information with its neighbor. Over rounds of interaction, it not only learns from its own interaction, but from the entire network. And it basically helps update information about their own self as well as the surrounding. So for example, when Alice learn from the surrounding that she may be interested in a protein bar because she looked into the protein bar. For Bob, the learning could be that he is buying Greek yogurt, and Greek yogurt as a product feature uh, is consumed by people who are health conscious. So there's a likelihood that Bob may be a health conscious person. And these are some examples. However, with a round of message passing, there's a lot of context is generated, and that generated context is stored in embeddings. Now the next step is to score, and predict. So for that, we'll take the exact same example from the beginning. So we know that Alice saw protein bar but did not made any purchase. So what is her probability of redeeming this offer when a offer is given to her? So for that, we create embeddings for Alice. That can be her shopping behavior, preferences, sensitivity, and another vector for protein bar, which can have different product features. These are dynamically created features, and GNN has learned with data. Now let's combine these embeddings. So for combining, we can take a simple dot product. There are multiple methods. For simplicity, we have taken the dot product between the two embeddings, and the after applying the sigmoid function, the probability that comes out is 73%. So which is a good likelihood of Alice to redeem this offer. And in a similar way, this can be done for millions of customers, and similar calculation can be done. And this is how scoring would actually help identifying the right customer, and then offer prediction would help us actually creating the bank with which we can do the recommendation. Now let's talk about the loss function. So up to this point, we have talked about different constraints used in model training. So these constraints was how do I maximize the redemption rate, minimize the redemption cost, and apply budgetary constraint. So to do this, we used multiple methods of creating the loss function. However, we ended up using the weighted sum loss, where each constraint was added together with their coefficient, and some negation was applied for the values where we need to change the direction of that constraint. So the key findings that we had, again, I am handcuffed due to the DHIP, but I'm just giving you some top line learning. Since we addressed the problem from the root, it helped us improve the engagement rate by 20%. We ran into few sparse labels where there were few redemption rates, so we had to do some resampling. Since the loss function was multivariate, so we saw some leakage when we pushed redemption rates. We ended up raising the redemption cost. So our next steps are to start working on a smarter dynamic loss function so that we can avoid the above problems, and then incorporation of a budget aware sampling, explore alternative of graph representations. So with that, I'll conclude my session. However, I want to sum it up what all things that we have learned. So as we know, retail keeps evolving. Hyper-personalization is no longer an option. It's essential. By blending in a predictive model with intelligent optimization, we can deeply understand customer behavior to deliver offers and campaigns that truly resonate. Don't underestimate foundational approaches. They may offer a very powerful method with which we can solve complex problems. At this time, innovation in science is very crucial. Our customer attention is becoming very sparse, and it requires newer method for us to stay ahead of the curve and to identify the insights and the methods of engaging those customers. So how do we calculate the success formula? So the key aspect of that is science, speed, and automation. So technique like spectral clustering empower us to build offer real-time relevant offers. Those are provide value to the customers, as well as client also approve them, so that we can elevate the shopping experience as it happens. In the end, it's all about using the data to make smarter decisions that translate into meaningful business outcomes. So thank you very much. We'll end here today. We'll open the floor for questions. So feel free to ask any question that you have for us.
Wow.
Thank you very much.
Wow. That was fantastic, man. I can see the clapping emojis coming up, the heart emojis. Please, again, stick a comment in the chat as well. It's always nice to know who it is that's putting the emojis up, and I'll give a few shout outs as we go. But already There's some fantastic questions in there. I'm just going to call out, this is why we love dunnhumby as a partner. Every single time you come with the really innovative content, and you really come with such a good presentation style to get stuff across for people in the community. So massive thank you from me on behalf of the community. And I can already tell this is going to be very popular on our YouTube channel. So I'll keep you updated with the stats as we get going. First of all, in the chat, Andrew Middleton, thank you, Andrew, for jumping in. The chat's been a little bit shy today. There's like 90 odd of you out there. Come and say hello. Andrew Middleton, kicking us off. Thank you for the great talk. Rosemary, this was the most interesting data science session I've attended this year so far. So that is definitely a compliment. Irene, agree in capital letters from Irene. So again, if you're putting comments in, please feel free to change it to everybody. When you're putting it in and you can see it. What I may ask to do, if you could stop sharing the screen, that'll make our faces a little bit bigger, which is maybe a good thing, maybe a bad thing, I don't know, depending. And we'll jump through some of the questions. So if I could ask you both just to open the Q&A feature. There is the ability within the Q&A to upvote. So if you see someone else's question you like, you can upvote it. And if I could maybe ask you to change the filter at the top right where it says most recent, we'll just change that to the most upvotes. So I'll start with the most upvoted questions first, and then we'll go through from there. So the first question at the top there that I can see is from Helena. Any tips on how to apply this approach to a business with low repeat rate, e.g. customer makes only a few purchases per year? And I think this question came in relatively early in the presentation. But in terms of that, can either of you perhaps speak to when you've got, you know, limited data, low repeat rates and stuff like that?
Yes, David. I think I did answer this already because we ran into this problem as well. So we did an oversampling, and based on that, we were able to resolve this problem. However, you can connect us offline, and we can understand the problem in a better way and guide you how you can approach this.
Ramesh, offering some consulting as well. You're too friendly, man. Prepare yourself, Ramesh. You're going to get lots of friend requests on LinkedIn now. The second question at the top there, it's a similar type of vein, but again, I'll fire through all of them. And again, if you feel like it's been covered, you know, let us know. Next question there at the top. Thanks for the excellent explanation. How does the GNN deal with new products with no limited previous interaction data?
For that, there are labels that you can pass. You can identify the similar products that are available as an alternative, and based on their historical behavior can be inputted to actually make some predictions. So you can try that. But I think this is a really interesting question. So far, we did not consider this one of the factors. So thank you for sharing that, and we'll think about it and probably come back to you as well.
Amazing, amazing. I did see in the comments that you were also joining us from Milton Keynes. So excellent question, and also in Milton Keynes, which is amazing. I'll maybe come to you, Vindhya, for the next question there. It's a bit of a more generic question, actually, rather than specific to this talk, but we do get questions like this quite a lot. So it's nice to perhaps support the community. I know both of you have been at dunnhumby for a number of years, and you clearly enjoy it, and you clearly enjoy working in retail analytics. But the question we have at the top there is how to transition into retail analytics, specifically that they ask from pharma analytics. But yeah, maybe, you know, people starting out in the industry or people looking to transition into retail, have you got any tips?
No, I think I would say it's definitely possible to transition into retail. I think it is about knowing the data and making sense out of the data. So the techniques come later, but I think when you know what you want, you know, when the objective is very clear, you know, so suppose in our case, we were very clear that we wanted to predict something which has not been predicted in the business before. And that is where we start to explore the techniques. So I believe if that is possible, definitely. And I think we are more than happy again to connect offline, you know, to help this individual get into the space if he or she is really interested.
Amazing. Yeah, really appreciate that as well. In terms of that then, again, super quickly perhaps, but when you're hiring at dunnhumby, you know, what type of thing do you look for? Do you look for that really good foundation in data? Do you look for like sort of ways of thinking? Do you look for a mixture of skills with a bit of commercial awareness? You know, what type of thing do you look for people just sort of starting out in their career?
Yes, I think we do get candidates who have not particularly worked in retail, but again, similar to first question, the analytical understanding, the logical reasoning, the communication, if you are really able to think on your feet, and innovation, I think all of these factors, your approach to solve a problem, are you really a problem solver? I think, the kind of solution that you can provide, in terms of any open-ended business question is what we really look at, David. And the rest of the things follow. Definitely, the technical part is something which can be learned over
Yeah.
time, but the strong skill set of analysis and data understanding forms the core foundation.
Amazing, amazing. Absolutely love it. Thank you for sharing that one. The question I've got at the top then is from Stefan. Good to see you, Stefan, actually. Not seen you for a little while. I hope things are going well. The question there, thank you, from Vindhya's section. Is it a problem if the training data consists of offers received because the customer is predicted as likely to redeem it? In which case, customer segments will only be exposed to the offers they are likely to respond to. Do you have to include random offers as well, or is it possible to remove the likelihood bias through something like causal inference? Does that jump out?
Yes, so not sure if I understood the question correctly, but in terms of our model, yes, we actually took every kind of possible offer type that we had in last 1 year. So that is where I said when we started with 2,000, 3,000 products, and we know we wanted to at least predict for these 2,000 plus products. We were very sure that they have a good sales coverage for the retailer, and they are like the most contributing products for the retailer. So we did start with every type of discount and offer that was possible. Obviously, I think, as I said, this is the first model that we built. This is something very foundational, and we are still exploring. So I think the suggestions are more than welcome. But yeah, I think we are still trying to make it as dynamic and real time as possible.
Amazing. Thank you very much. I'm a little conscious of time. We do try to keep this to that 1 hour time slot. I'm going to take two more questions. I'll take one from the chat and then I'd just a little side one of my own, if that's okay. Have you both got a couple more minutes just to fire through? Thank you so much. Again, why we love dunnhumby. This is the dedication that we're looking for. So I'll tackle Andrew Middleton's question from the Q&A. Andrew says, apologies if I missed it. Is the iGun decomposition used using principal component analysis? And is there a reason why you would not use iGun decomposition rather than other methodologies like UMAP? And I think maybe that was aimed at you, Ramesh.
Yeah. So again, when I explained eigenvalues, it was done to actually explain the concept and walk you through the similarity. But however, the calculation was slightly different. And again, with this time limitation, it's really tough for me to actually explain the nitty-gritties of how it was done. But like I said to every participant, so if you are interested, I'll be more than happy to discuss this in detail, and we can walk through the how and how did we do it. I'll give you some dummy examples for sure, but because we need to protect the IP. But the way we did it actually helped us decompose those vectors into smaller space, and we were able to run k-means clustering with very ease. So the method was very effective.
Amazing. I think we're going to have to get you to come back, both of you, aren't we? And get you to do a follow-up session. But I guess just drawing things to a close, I think we're in an amazingly positive time in the data and AI world at the moment. And I think there are so many new AI techniques, data science techniques, new algorithms and approaches. Could you perhaps speak to, how do you decide, what the right one to start with, is, if there is so much choice out there, so many opportunities, how do you home in on what to tackle?
Yeah, so I think I can maybe go first, and Ramesh, feel free to chime in. But I think it all starts with, again, what you want to achieve. So the clarity of thought is very important. Like the business objective has to be very clear. I think Ramesh did conclude with a very good point that you can always start with something exploratory, simple, foundational, and then keep on exploring and improving your model over time. So I think that's the beauty, that we don't stop. I think we should try all the techniques possible, which all techniques which basically fit your business problem, and then select the one which is giving you the best results. So that would be my take. But Ramesh, happy to hear your thoughts as well.
Absolutely, Vindhya. I think in during the entire course of the presentation, you would have noticed that we started with something foundational, and we experimented with that. We knew what kind of output we can expect, and then we went into the next methodology, and then scaling, then understand how it's performing, and then further scaling it. So this is the approach that is very effective, because you know from different learning that what is your baseline and where do you want to reach, and whether that algorithm that you're applying would be effective, because we as a business has to be very cost conscious. You can have any number of algorithms, you can have biggest transformers available, but at the end of the day, if you cannot put those things in production, you need to be mindful of those things as well, because developing POCs is really interesting, but as a business, the things goes into production, so we need to be production first. Thoughts should be there while creating any algorithm or thinking about any algorithm. Just understand their scaling potentials.
Fantastic, fantastic. What a session. Thank you so much. As mentioned, it is going to be, or it has been recorded, will be on our YouTube, hopefully within the next few days, if not certainly very early next week. But I am just going to draw things to a close by saying thank you both very much. I say it after most of these webinars, but it's not just the time that you've given up now, it's also the time in preparing the slides and joining the practice session. So really appreciate you both supporting the community. And I mentioned it at the start, and I'm definitely going to finish by mentioning it as well. dunnhumby are absolutely one of my favorites. They are fantastic company. I know they always do great work, and they are very much at the forefront of supporting the data community globally. So massive thanks to dunnhumby. Last comment from Tara: dunnhumby always delivers. It is very true. So thank you very much. How did you both enjoy it? Was it good fun?
Yes, I think I forgot to say in the start, but this is the best time to say thank you so much, everyone. I think this is first time for us, and we're just so overwhelmed with the response. Thank you, data science community. Thank you, dunnhumby, for supporting us. And thank you, audience. I mean, it's the best audience that we have seen so far.
Amazing. Glad you enjoyed it. What about yourself, Ramesh? Did you have a good time?
I think echoing Vindhya's thought, I truly enjoyed every moment of the discussion, and as a community, we need to learn from each other, share, and I've watched the other sessions as well, and this is how I've learned from this session, and this is the time for me to give back. So we took that time out.
Thank you all. And thank you for joining us wherever you are in the world. We look forward to seeing you again soon. Until then, yeah, stay safe, and we look forward to seeing you again in the future. Thanks.
Thanks, David.
Thank you.
Thank you.
Bye-bye.